Reconstruct Itinerary. You are given a list of airline tickets where tickets are is equals to from and to represent the departure and arrival airports of one flight. Reconstruct the itinerary in order and return it. All the tickets belong to a man who departs from JFK. Thus, the itinerary must begin with JFK. And if there are multiple valid itineraries, yeah, you should return the itinerary that has the smallest lexical order and when read when read as a single string. For example, the itinerary JFK. This is the firm, and the two LCA has a smaller lexical order than uh, JFK GB. So we can easily see that A comes before the B here, so that's why it has a small lexical number. You may assume all tickets from at least one valid itinerary. You must use all the tickets once and only once. So we see here example one. It shows that MUC goes to LHR. We can see that here, and JFK goes to MUC, and so on and so on. According, so the output we have to start with JFK as it shows over here. JFK, and then it shows the order that we go through. That's the visual image, and this one it's more it has well it has arrows pointing from into each other. So this one we have is larger, has more possibilities. So we can see this not as easy to see as this, but JFK does come to this to SFO, and then SFO goes to ATO also goes to SFO, and these two switch here, and it says that we have this, so we have to start from here. So JFK does come here. Well, it's in this. It says ATL, and also so this is another possibility. So this is a simple problem that we can solve. It's a graph problem. Problem. So let's make a graph. Adjacent dictionary to whole. So now let's move on to whole airports. Let's make graph and graph equals to default and then put list graph. So for from the first value is from the from, so from airport, second value is to the airport we're going to airport, and tickets. So let's take graph and then put out from airport, and then append to airport. So now let's uh, so now we have this. It does say that we have to make our lexical order. Wait, does it say we have to make a lexical order? So let's go through that. So let's make for every airport, and our graph. Let's make graph that airport and then append it. Oops, airport. I'll just take this right here. Call it lexical order. That's sort. This console method. So now we have this. So now let's make our list to hold our itinerary. Uh, let's call it itinerary to hold airport. Itinerary equals to list. So now let's make our DFS function to traverse our our graph. Def DFS airport. So now, so while we have an airport, while graph airport, let's pop it. Let's pop next. Let's call it next airport. Here. Next. Hold on. Next airport. Yes. Next airport, and then equals to next airport will be equals to hold on. Graph airport dot pop 0. So the smallest in the lexical order that we have it all sorted. So now we're going to call on the DFS function. DFS function. Def call it next airport, and then now let's add to the itinerary. So itinerary that append and then add airport to it. So now we have this. So while we have an airport, so then pop the value. So now let's move out, and we're basically done now. Let's call. We have to start from JFK. So JFK. And then return itinerary, and then since we have to reverse itinerary since things it's in backwards, it's in back in the reverse order. So let's see if there's any syntax errors that we need to fix. So graph default list for software to airport and that's it. It's that simple. any syntax errors, and it's been accepted. So our time and space complexities. So e of log e. So we can see that we have to go through every um uh and add it to our graph, and also the sort function, that's n of log n, or, or you can say e of log e, and our space complexity. V plus o v plus e. P is number of AirPods, and E is tickets. O of n log n. Sub built-in write down. So that's basically it for this problem. Let's take let's submit them to see if it's going to pass all cases. And it's been able to pass all cases. So that's it for this problem.